So Boran, you've done that. You've plugged these numbers in, generated the.
Yeah, so let me switch to, so this is what the file looks like that describes this. Once the infrastructure code, the code that actually does the work is there, for each subsequent model that I want to create, what I have to do is specify the nodes, the vertices of the unit, right, like this. And it's basically just copying down the information from that notebook. I can give them names for reference later on. What you call them doesn't matter at all as long as you use the same consistent name. And you specify the coordinates, and then you specify the edges. And you say these are the angles. It turns out the 45 degrees actually is 135 in this way of counting. So the valley folds and mountain folds, one of them is 180, the other is minus 180. I can never remember which one. I have to work it out in my head every time. But the half folds are minus 90 and plus 90. And then that 45 degree valley fold is 135. So you've specified the nodes and the edges. And then what you say is, now generate me something that's a crease pattern that uses these nodes and edges. And then if you look back at that image, the size of the area in the plane taken up by this unit is, this goes from 00 to 80. So if you wanted to translate this unit and make another one right next to it, you would move it by 8 units in this direction. And that's what that 8 refers to here. So in order to specify the repetition, and so what you want to do is you want to make a copy of it by reflecting it across 3 different lines. If you reflect this triangle across that, you get a copy of it here, symmetric part of it. And then once you have those two, you reflect across this line, and you get the 2 copies on the other side there. And finally across this line to get the rest of this square. That's one way to do it. In fact, if you call these 3 lines L1, L2, and L3, it doesn't really matter in which order you specify them. So I said, okay, take this minimum cell and then add a reflected version of it across line L1, which is the standard diagonal 0, 0 through 1, 1. Then add a reflection of all that across the line 0, 8, 1, 8, specified by that line. That's the actually the horizontal line up there, and then add a third reflection across the line that starts at 80 and goes to 81. And then if I want to generate a tessellation of that and say size 2 by 2, then, well, that's the first step, making that unit. And then you still need to figure out, you could probably do this automatically also, but I didn't bother at the time, how big that total unit that you're translating now, its size, and it's 16 by 16. So you have a horizontal translation by 16, 0, and vertical translation by 0, 16. And so then you just make that, do that translation and add it to the file, to the pattern. And then you can save that pattern. And so when you do that, yeah, so the 2 by 2 pattern that's generated is this. Right? The single pattern looks like this. The 2 by 2 is this, and then you get bigger ones. You can get a 5 by 5, which I have to zoom out the window to fully appreciate. But you can also get non-square patterns, right? So I think I generated a 5 by 4 there. And so these can be loaded into Origami Simulator